Hello, today our topic is testing diodes with an ohmmeter. What is a diode? A diode is a device that allows current to flow in one direction. The common types of diode are rectifier diode, bridge rectifier, signal diode, Zener diode, and light emitting diode. We have here the schematic symbol of the diode. Here we have an arrowhead, which is the anode. This is the positive electrode of the diode. We have here a bar, the negative electrode of the diode, and this is what we call the cathode. We have here a rectifier diode. We have here a band. So the band here is the cathode side. On the opposite side is the anode or the positive electrode of the diode. We have another schematic symbol of a diode, and this is the symbol for light emitting diode or LED. The usefulness of diode comes from the PN junction, which is between the layers of P and N-type material. This junction serves as internal contact potential. Controlling this potential across the PN junction makes it possible to control the current in a semiconductor. Here we have a magnified view of the PN junction. Notice how the barrier voltage is created in the junction. As you can see, some of the negative charges from the N-type material move towards the P-type material. Also, some of the positive charges from the P-type material move towards the N-type material. These opposite charges produce an electron-hole pair that are neutral. This effect at the junction uncovers the charged ions of the impurity atoms. The ions do not move. As a result, this charge provides a barrier voltage and prevents more electrons or holes from crossing the junction. Now the barrier voltage for silicon is 0.7 volts and for germanium is 0.3 volts. How does a diode conduct? Now we know that the diode has a barrier voltage at the junction, and it can be overcome by applying a forward voltage of 0.7 volts. The polarity of the voltage is plus forward voltage to the P electrode and negative forward voltage to the N electrode of the diode. What is the effect of the forward bias to the diode? As you can see, the negative charge are repelled by the electrons from the voltage source. The positive terminal likewise repel the positive charge from the positive electrode of the diode. Now, this action neutralizes the effect of the barrier voltage at the junction and offers a low resistance for the current to flow. That is how a diode conducts with a forward bias. If you are more familiar with conventional current, then the positive is also thought to flow in the opposite direction. Now we have reversed the voltage, or we are applying a reverse bias to the diode. Now we have connected the positive terminal of the battery to the cathode side or the negative electrode of the diode, and the negative terminal of the battery, we have connected to the P terminal or P electrode of the diode. And during the reverse bias, the electrons from the battery will attract the positive charge in the P-type electrode, and the positive terminal of the battery will attract the negative charge in the N-type electrode of the diode. This will further widen the depletion region. If the depletion region widens, then no current can flow. The junction is acting as a very high resistance. Now we are going to proceed with testing diode with an ohmmeter. First, we are going to test during the forward bias, and we are going to use range times 1. Now we have here a rectifier diode, and we are going to connect the red test probe to the cathode and the black or the positive test probe to the anode. As explained from the last video, when using the ohmmeter, the polarity of the test probe is reversed. So, meaning the red test probe provides the negative and the black test probe provides the positive. Now, the needle of the meter should move towards low resistance because during forward bias, the diode will conduct. And this is a good indication. Now, we test the diode in the reverse bias. So we connect the red test probe to the anode and the black test probe to the cathode. Again, we are using range times 1. Now, because this is reverse bias, the needle of the meter should not move at all. And this is a good indication because during the reverse bias, no current can flow in the diode. Now, when we test the diode in the reverse bias, and if the needle of the meter moves towards the low resistance, then that is an indication of a shorted diode. So that is a bad indication. Still, we are using range times 1. Now to test for a leaky diode with an ohmmeter, we're going to do this in the reverse bias. But now, we're going to use range times 10K in our ohmmeter. Again, we connect the red test probe to the anode and the black test probe to the cathode. Now, if the needle moves a little towards the low resistance, then that is an indication of a leaky diode. So this diode should be replaced. We'll proceed with testing LED with an ohmmeter, and we're going to use range times 1. So this is how we are going to test an LED with an ohmmeter. We need to determine the negative from the positive terminal. Now, the shorter leg is the negative and the longer leg is the positive. We are going to connect the red test probe to the negative of the LED and the black test probe to the positive of an LED. Now, if the LED is lit, then the LED is good. So I hope you learned something from our topic, and I hope to see you all next time.